Hi there, Pre-Calc students. Welcome to the last of our presentations from Chapter 10 on the conic sections, this one on 10.5 parabolas. Here's the definition for a parabola. As you can see, it still has something to do with the distance from a focal point, but the set of all points in a plane that are the same distance from a given point, only one focus here, and this time the distance is also measured from a line called the directrix. Now here's a nice chart that would be wise for you to copy down, so you may want to pause this and copy this chart down. Again, we have our standard form equations, two of them for parabolas, depending whether they are have a horizontal orientation or a vertical orientation, as you can see here. And vertex is the same as it has been, H and K. Focus point, remember there's only one point here, a little bit different, and we'll get to that as we go through some examples here, but make sure to get this chart down in your notes. Alright, we're just going to go right to an example here, and we would like to try to find the vertex, the focus, the directrix, then we're going to try to graph this particular parabola here. Now, as you can see, just judging by what this looks like, this is going to have a vertical orientation. Anytime you have an x squared, it's going to be the vertical orientation, and the y squared will be horizontal, as you might guess. Now, we can tell right away here that our vertex is going to be the point 3, -1. That's pretty similar to what we've seen in our other conic sections. Now, one thing that we really will focus on, though, is this value right here. That number that's multiplied by the other expression, the other variable expression, is called 4p. So in this case, we can see that that 4p is going to be 8, and so that means, of course, that p will be 2. Now, that's going to be a very important distance because that is going to be the distance from the vertex to the focus, and also the distance from the vertex to that directrix line. So that's a very, very important thing for you to always try to figure out with parabolas, is this p distance here. Alright, now we're going to go and actually graph this so we can see. And so here's my graph here. I'll see if I can be a little bit more accurate. Our vertex, we said, was the point 3, -1. So I'll try to put my dot right there as best I can. Okay. We know that it's going to be opening upward based on that that p value was a positive number. That tells us that this is a parabola that's going to open upward. But how do we go about graphing this? Well, once we have that focus point, remember we figured out that that p value was 2. So that means that from the distance from this vertex point to the focus will be 2 in this direction. The distance from this vertex point to the directrix will be 2 in this direction. So what it's going to look like here, we're going to actually graph this directrix line, which is going to be 2 units down, so it's going to be right here. So that directrix then has the equation y equals -3. Our focal point then is going to be up here at this point, which is going to be 2 points, or a distance of 2 bigger than the vertex there. So there's our focus point. So our focus is going to be that particular coordinate there, which is 3, 1. Now, how do you tell how to draw this parabola? Well, it's kind of interesting in that 4p distance, which we saw in that last slide, was 8. That's going to be the distance here that's kind of going to span that parabola. So I'm going to count over from my focus point here 4. So 3 plus 4 is 7. I'm just going to put another little point there. And 3 minus 4 is at -1. So that's going to give me a guideline as to how to draw my particular parabola here. So I'm going to try drawing this like this. There we go. So this distance right here has a special name that is on the same line as the focus, kind of spans that. I'm going to award 10 points on your critical thinking right away for the first person who can tell me this tomorrow morning. What is the name of this distance that spans this parabola right here? Also, it's can solve this for y. This is a little bit similar now to what we have done back when we were studying about transformations of functions. You recall, here's our original equation of this parabola. Is it possible to solve this for y? Well, yeah, the first thing we could do is divide both sides by 8. So then it looks like this. And then if I solve this for y, I'm going to rearrange things a little bit. So it will be y equals 1/8 x minus 3 minus 1. And you might remember from our study a while back that sure enough, here's our vertex point. Here's 3, -1. This number here, since it's a number less than 1, is going to flatten out that parabola a little bit. It's still going to be opening upward. So this is a good way to check to see if you've graphed your parabola correctly. To another example here, and you probably recognize this now as being one of these examples that we would say is in general form. And so as you might guess, we're going to try to get this in that standard form so we can work with it better. Once again, we're going to try to group our y's together like this. And this time I'm going to get all my y's on one side, all my x's on another side. So it should look like this. And I'm going to try to complete the square here. Now you might notice that because this is a y squared here, this is going to have a horizontal orientation, as you might have guessed. So once again here, when I complete the square, I of course focus in on this value here. I take half of that, which is 1, and I square 1, so I know I'm going to have to add 1 to each side like this. And so now when I actually complete the square here, this expression is going to be y plus 1 squared. Over here, meanwhile, it's going to be -12x plus 24. So on the left side, that's the form that I want if you look at your standard form of parabolas. On the right side, I'm just going to factor this a little bit. I'm going to pull out that -12, and so then I'm going to have x minus 2 there. Now we can clearly see that our vertex here is going to be careful with your x's and y's here now. So our vertex is actually going to be 2, -1. And sure enough, we have this value here for that 4p. So when we go on to our next slide here, we're going to graph that so we can see what that looks like. Alright, here's my graph here. We said our vertex was at 2, -1. So that's going to be right there. Let's see if I can plot that somewhat accurately. There we go. That 4p we said, remember, was equal to -12. That means that p is equal to -3. So in this case, because and by the way, because that is a negative number, I know that my parabola is actually going to be opening to the left. Left if this p is negative, right if it's positive. In this case, it's going to be negative. But my directrix then is going to be 3 units from this. So I know it's going to be 3 units to the right. So that directrix, that particular line, is going to come down here right at x equals 5 is the equation for that. And then my focal point is going to be 3 units over this way. So there's my focus right here at -1, -1. And remember the way we said that you could figure out how to know where this parabola goes is, you might recall that that 4p value was -12. That means that this span here is going to be 12 units in length. So I know that it's going to be up 6 and down 6. So it's going to go right about to from here to positive 5, and then down here to negative 7. That's going to help me when I graph my parabola here. So it's going to actually look like this. There we go. And once again, if you can, the first person who's going to tell me what the name of this span is, very unusual sounding name, I'll give you full credit for your critical thinking. But you have to do that in person tomorrow morning. So that's a little introduction. Parabolas maybe are the most useful or most seen of the conic sections. Here you see some examples like satellite dishes. There's the Great Arch in St. Louis, good example of a parabola. And here you can see these porpoises, these are dolphins here. Kind of gave away my little joke because my little joke was going to be why don't dolphins do anything by accident? And the answer is, of course, that they do it on purpose. So anyway, we'll see you guys tomorrow, and have a good night. Bye now.